Welcome to Mitchell Maths. In this video we are going to have a look at Pythagoras' theorem. Now Pythagoras' theorem states that a squared plus b squared equals c squared. Now this theorem only works with right-angled triangles, so if the triangle's not right-angled you can't use this. And what A, B and C stand for is the length of the sides on the triangle. If we have a look at C first, C is always a hypotenuse, and that's going to be opposite the right angle. So if we go to this triangle I've just drawn, and if we go to the side opposite, that's going to be C. And A and B, it doesn't matter which way around you write them. I'm just going to write A here and B here. And yeah, this works for right-angled triangles. So if we have a look at the question, find the length AC. Well, the first thing we want to do is we want to label the sides of the triangle. So we go to the side opposite the right angle and we label that C. And the other sides can be labelled A and B in any order. And then we need to put the numbers into the formula. So 6 is A, so we've got 6 squared. We've got B, which is 9. B squared is 9 squared, and that's going to equal C squared. 6 squared plus 9 squared is 117. And we know 117 is equal to C squared. And in order to find C, we'd need to square root both sides. Therefore, C equals the square root of 117, which is equal to 10.8 centimetres. Always write down the sides first, so label your sides A, B, C, and then put the numbers into the formula. Question 2, find the length of AB. First thing we're going to do is we're going to label the sides. Well, the side opposite the right angle is going to be labelled C, and then the other sides can be labelled AB in any order. So I've got A squared plus B squared equals C squared. If I have a look at this triangle, I can see that the length I want to find is B, but the formula is A squared plus B squared equals C squared. In order to find B, I'm going to need to rearrange this formula and get B squared on its own. Therefore, I'm going to take away A squared from both sides. And that will leave me with B squared equals C squared minus A squared. Now I can put the numbers in order to find B squared. So C is 14. I've got 14 squared, take away 9 squared, which equals 115. Therefore, B squared equals 115. And in order to find B, I'm going to need to square root both sides, which is going to be B equals square root of 115, and that's equal to 10.7 centimetres to one decimal place. In this question, it's a little bit harder. We haven't been given a straightforward triangle, but we can use Pythagoras' theorem to find the distance between A and B. We just have to insert another line here. So sometimes you're going to have to look at shapes and see if you can arrange them differently in order to use Pythagoras. It's also the same with trigonometry. But we do have a right-angled triangle. Now we can see the length of the base of the triangle, because if D to C is 12 metres, then this must be 12 metres. And we can find this length here, the vertical length here, by doing 28 take away 20, which is 8. And then we can label the sides C, A, B. As I say, A and B, it doesn't matter which order you write them in. A squared plus B squared equals C squared. That's going to give us 8 squared plus 12 squared, which is 208. C squared equals 208. Need to square root both sides. That means C is going to equal square root of 208, which is 14.4. And that's in metres, because these sides are in metres, not centimetres. In this question, we're being given 2 points on a graph, and when you're given 2 points on a graph, you are able to use Pythagoras' theorem to find the distance between those 2 points. What we need the vertical height between the 2 point distance, and we need the horizontal distance. And you can see if we draw it like this, it makes a right angled triangle. Well, the vertical distance can be given by the y coordinates. 13 take away 1 is 12. And the horizontal distance can be given by the x coordinates. 8 take away 2 is 6. Now that we've got the horizontal distance and the vertical distance, we can label our triangle so opposite the right angles here, so that's C, and we've got A and B. And then again, now that we've got this, it's just plugging numbers into the formula. A squared plus B squared equals C squared. We've got 12 squared plus 6 squared equals C squared, or equals 180. Therefore, if C squared equals 180, we're going to need to square root both sides. C equals the square root of 180, which is 13.4. And 13.4 is the length of AB. We don't have any units here because we weren't given any units on the graph. It didn't tell us we were using centimetre, graph paper or anything like that. So we just leave the answer as 13.4 to 1 decimal place. Right, so we've got a proof question. Well, we have to decide whether a triangle with 6.5 centimetres, 7.2 centimetre and 9.7 centimetre sides is right angled. Now, we always know that in a right angled triangle, hypotenuse is always going to be the longest of the 3 lengths. So if this triangle could be drawn as follows. We'd have the right angle there, we'd have 9.7, 6.5, 7.2. And if this triangle is right angled, then it should follow the formula A squared plus B squared equals C squared, where C is the hypotenuse, A, and you've got A and B. Therefore, what we're going to need to do is we're going to need to do 6.5 squared plus 7.2 squared to find C squared. So 6.5 squared plus 7.2 squared gives us 94.09. And then we square root, to find C squared, we need to square root 94.09. And that gives us 9.7. And because this triangle follows Pythagoras' theorem, that means that it is a right angled triangle, because if you try that with a triangle that is not right angled, it won't work. So that proves, yes, it is right angled. And the final question. Right, so here you've got a circle with a diameter of 10 centimetres and a square has sides of length 7 centimetre. Will the square fit inside the circle? So you might think, well, this doesn't look like Pythagoras' theorem. What we need to do in this question is we need to find the diagonal length of the square. Because if we put the square in the centre of the circle, if the diagonal length is less than 10 centimetres, then it will fit in the circle because 10 centimetres, it'll be less than the diameter. If the diagonal length is more than 10 centimetres, then it won't fit inside the circle. And in order to find the diagonal length, well, we know square, all lengths are equal, so that's 7 centimetres, 7 centimetres. And we know that the angles in a square are right angles. So we can use Pythagoras' theorem to find the diagonal length. And you can use a similar method also if you have a rectangle to find the diagonal length. I'll label the square sides A, B and C. And if we put them into the formula, a squared plus b squared equals c squared. We've got 7 squared plus 7 squared, which is equal to 98, 49 plus 49. And if we want to find what's c, if we want to find the diagonal length of the square, then we're going to need to square root 98. And the square root of 98 equals 9.9 centimetres to 1 decimal place. And if we look at the diameter of the circle, that's 10 centimetres. Well, 9.9 is less than 10 centimetres. Therefore, yes, the square will fit inside the circle. And I've seen that type of exam question has come up before. It was on one of the specimen papers. Right, thank you for watching. I hope you found that video helpful. If you'd like to see more videos, please hit the subscribe button. And for practice questions, please visit the website www.mitchellmathsandscience.com.